Hello everyone, thanks for tuning in. Today I'm going to show you further on the Smith chart using FILPAL EDS. So I have launched the software and this is the icon for the plot. Then I can choose Smith chart. Okay, so you can see on the right hand side is the Smith chart. So under the generic toolbox I can choose the lump element. Before I choose, perhaps I can guide you through a bit on what we learned in the previous video. So on this side is the short circuit end, this is the open circuit end, this is the inductive region, and this is the capacitive region. So I want to do one thing using this Smith chart, which is the impedance matching. So let's design the L section matching network to match a series load with an impedance Z equal to 200 minus J 100 ohm. So I can plot this impedance, the 200 and minus 200 ohm. So we know this is the capacitor, but because we want only the value of 100 ohm, we have the alternative, which is the frequency invariant reactance. So the value is minus 100 multiplied by J, and then I give the ground here. So I would like to do the matching here. To 100 ohm. So I bring the port of 100 ohm. Right, and then the match should be at 500 megahertz. So I have to change this to 500 megahertz. This is the frequency range. So here is 500 megahertz. Then I click plot. So obviously you can see here it is at the lower side, which is the capacitive region. Now I want to do the impedance matching, means that I have to add a section in between here, so that when I look into this point will move to the center, which is the place where you can see that this is purely real at the value of 100 ohm. So let's try to take a capacitor in, right? So I put the shunt capacitor, and then I also provide the ground for that. So at the beginning, I just make it 0.1, but because I want to tune it, I do not know the value initially, then I put it as X variable, and then put this as picofarad. So I just at the very starting point, I make it the small value of 0.1. Then I try to simulate. So you see it move down a bit. Then I tune it down. So I can make the step to be 0.1, and then maximum maybe 10 or 100 is up to you. So then I can move, see when I increase the value, it will move to this way. This is the clockwise direction. So I have to move until I reach the real part to be 1. So now my real part is 0.9, which is above or past 1. So I have to reduce the value of this to smaller. Okay, so here I can see it's as 1.018, which is higher than 1. So I have to increase a little bit, meaning I cannot increase the step size at 0.1. I have to make it smaller. So 89. So you see it's dropped to 1.026. One more, 34. So meaning if I decrease, it will go to this side. Then I have to increase it. So meaning is more capacitive here, but because we effectively add it. Okay, so you go up. Okay, so now it's 0.994. Down a bit, 1.002. I think I will take this value at the moment. Okay, if you want to have more accurate value, then you can decrease the step size. Then I can add one more. You see it get closer to 1. then 2, almost. Alright, this is perfect. So the real part is 1 now. Then I can set this as the false value. So I know that no matter how much I change this value, it won't move this to the center. And we know when we add the inductor, meaning we will want to bring this up to the inductive region, then if we add this inductor and then we make the value of this inductor to be let's say 1 nanohenry, or because we want to tune it, we just make it as y, and then this becomes 1. Then I can click run again. So you see it goes up a bit. Then I tune it. So let's say I make the step size to be 100, sorry, the maximum to be 100, and the step size to be 10. Let's see it will move up. So until we reach 0, now you see it's moving too much to this direction, the clockwise direction. Then I change my step size, make it smaller, 1 more. So this is this number, almost 0. Then I can change the step size to be smaller. So I can decrease it. Then I check 0.03 minus, meaning at the lower. So I need to bring it up. Right? So it's too much up. Then I can bring it down. And then it's already still up. Then I bring 1 more. Now it go to minus. So meaning I have to make my step size smaller. So now it is in the capacitive region. So if I want to bring it up to 0, then I have to add more inductor. See 0.002, 0.002 still, 1 more, still, yeah, this is increasing to 0.001, 0.001 still, yeah. So now you get your impedance matching done, which is very useful, because when you add the series inductor, then it would try to move it to this side, to the inductive region. And if you add the capacitor, it will try to move it down to the capacitive region. Thank you for watching. Have a nice day.